Ever wondered how industries move thousands of liters of water, oil, or chemicals every minute? The answer is a centrifugal pump, one of the most widely used machines in the world. In this video, I'll show you exactly how a centrifugal pump works with simple visuals and real-world examples. Definition and basics. A centrifugal pump is a rotodynamic pump that uses a rotating impeller to impart velocity, pressure to a fluid. Converts mechanical energy from a motor, kinetic energy, pressure energy. Main components. Casing, volute, diffuser, directs flow, converts velocity to pressure. Impeller, heart of the pump, rotates to impart energy to fluid. Suction nozzle, fluid enters here, usually at the center, eye of impeller. Discharge nozzle, high pressure fluid exits here. Shaft and bearings, transmit motor power, maintain alignment. Mechanical seal packing, prevents leakage. Wear rings, protect casing and impeller from erosion. 4. Working principle, step by step. 1. Fluid enters pump through suction nozzle, impeller eye. 2. Impeller rotates at high speed, throwing fluid radially outward by centrifugal force. 3. Velocity of fluid increases, casing, volute, diffuser, converts velocity, pressure. 4. Fluid exits at higher pressure and flow rate through discharge nozzle. Key concept, centrifugal pump equals velocity energy plus pressure conversion. Performance parameters, head H, energy per unit weight M. Capacity Q, flow rate mCor/hour LPM. Efficiency Y, output power / input power. NPSH, net positive suction head, prevents cavitation. BEP, best efficiency point, safe operating region of the pump curve. Applications, latest use cases. Oil and gas refineries, crude transfer, process fluids. Water supply and treatment, city pipelines, desalination. Power plants, boiler feed water, cooling systems. HVAC and firefighting systems, circulation, safety. Chemical and pharma, handling acids, solvents, slurries. Advantages, simple design and easy maintenance, can handle large flow rates. Smooth, continuous output. Compact compared to positive displacement pumps. Limitations, challenges. Not suitable for very high pressures, better for high flow, low medium head. Cannot self-prime, needs priming before operation. Cavitation risk if suction conditions are poor. Future trends, 2024 to 2025. Smart pumps with IoT monitoring, vibration, pressure, temperature. Magnetic drive pumps, no leakage, safer for chemicals. Energy-efficient impeller designs for sustainability. Integration with AI predictive maintenance. Mini quiz, quick question for you. What happens if a centrifugal pump runs without liquid? Drop your answer in the comments. Top 5 interview questions and answers. 1. What is the difference between centrifugal and positive displacement pumps? Centrifugal pump imparts velocity, converts to pressure, best for large flow and low medium head. Flow varies with pressure. Positive displacement pump traps fixed volume per cycle, best for high pressure and low flow. Flow is almost constant, independent of pressure. 2. What is NPSH, net positive suction head, and why is it important? NPSH available, NPSHA, actual pressure head at suction above vapor pressure. NPSH required, NPSHR, minimum head needed to avoid cavitation. Importance, if NPSHA, NPSHR, cavitation, vibration, seal bearing damage. 3. Explain cavitation in centrifugal pumps and how to prevent it. Cavitation, formation and collapse of vapor bubbles when suction pressure, vapor pressure. Effects, noise, vibration, erosion of impeller. Prevention, maintain NPSHA, NPSHR, increase suction head, reduce fluid temperature, use inducer. 4. What is BEP, best efficiency point, and why should pumps be operated near it? BP, point on pump curve where hydraulic efficiency is maximum. Reason, operating near BP reduces vibration, radial thrust, power consumption, wear, increases pump life. 5. Why are centrifugal pumps not self-priming? Because impeller cannot compress air, needs liquid at impeller eye to create suction. Must be primed with liquid or use self-priming designs with recirculation chamber. And that's how a centrifugal pump works. Simple but powerful. If you enjoyed this explanation and want more engineering breakdowns, don't forget to like, share, and subscribe to 3D Decode. See you in the next video.